Hello everyone, this video includes the lecture recitation 1 for the course ECE 6397 Machine Learning and Computer Vision. My name is Najma Parveen and my people's of ID is 1950506. So in this video, we are going to address 5 different questions. The first question is when we train a deep neural network and if the validation data does not perform well, then what tools we can use to improve the deep learning network so that the validation and the data validation improves and these tools work. So the following tools can be used. The first one is the dataset collection and cleanup. If the given data set is filtered by using more number of convolution layers, and the number of data sets is also increased so that the network can be trained for a wide range of features. The next tool that can be used is data augmentation. The given data is augmented by using simple techniques like rotation, random cropping, shifting, flipping to generate more samples of the given data. So when we have more samples of the given data, then the data can be recognized even when it is performed in, even when it is presented in different forms. The next tool that can be used is the hyperparameters tool. In this, we have two parameters, that is the batch size and the learning rate. So the mini batch size is if when a data is given, it is analyzed by changing the batch size. So this improves the training process. And another way of improving the training process is by is the learning rate. The learning rate changes itself during the training process, and it controls how much the model needs to be changed once the whole cycle of training completes. So each time the training completes, the model weights are updated, and the learning rate decides based on the errors and the model weights about how to change the model for a better outcome. The next question here is what are the 3 motivations for using more layers in a deep neural network? If we use more layers in a deep neural network, the network can be trained for more complex features and thereby do extensive feature extractions as compared to shallow models. Also, with more number of layers, the model can be generalized with more features for a greater range of inputs and can perform abstract representation of the input. The input, if a given input is of multiple dimensions, then that can be easily trained if we have more number of layers. So the third question that we have here is, why is data normalizations important before training a deep neural network? In general, data normalization is very important for any purposes because it improves the accuracy and reduces the time taken in any process. And especially in a deep neural network, data normalization is used so that the learning speed of the network increases and it leads to a faster convergence. And to obtain a mean that is closer to 0, it is also important to normalize data so that the validation accuracy increases. The fourth question here we have is, describe the normalization methods while training a deep neural network. We have 3 normalization methods: the batch normalization, layer normalization, and weight normalization. In a batch normalization technique, in batch normalization technique, the input layer is standardized for each mini batch. This increases stability of the neural network, and the output of the previous activation layer is also normalized by subtracting the batch mean and dividing the batch standard deviation. That means that in this process, the layer is segmented into mini batches, and the mean and standard deviation of each batch is calculated, and the output is normalized based on each values of the mini badges. But there are a few drawbacks of this method, and that is because we are calculating mean and standard deviation of each batch, it needs a more computational time. So to overcome that, we are using weight normalization method. Um, and in this normalization method, it separates the norm of the weight vector from its direction. The normalization occurs with the weights of the layers. And in this method, the number of weights tend to be far smaller than the number of inputs. So the computation is cheaper compared to batch normalization. The third method is layer normalization. In this method, the entire layer is normalized during the training process. The next question that we have here is the part one of the fifth question. Explain why good initialization is essential in training a deep neural network. Initializations of the weights is one of the important factors while training the network. If the weights are not initialized in a proper manner, then there are two problems that can arise. The first one is vanishing the gradient problem, and second problem is explode gradient problem. So if we initialize the weights of a neural network, and the weights are very small, then the gradient gets smaller while backpropagating. So as a result, the neurons in the previous layers learn slowly when compared to the neurons in the later layers. So this problem occurs when the weights are initialized too small. But if the weights are initialized very large, then it causes the gradient to get larger. As a result, while updating the parameters, high weights are updated and overshooting the minimum values. So to overcome these two problems, we use the Xavier initialization. So that is a part two of the fifth question. The strategy of Xavier initialization is as follows. We have two problems. Either the weight is more initialized in a larger value, or the weight is initialized in a smaller value. But what the Xavier initialization does is it adjust the weight in such a way that it is the right weight for our network. And this is done by using a random uniform distribution that's given here, that is plus or minus root 6 by root over ni plus ni plus 1, where ni is the number of incoming networks and ni plus 1 is the number of outgoing networks. Thank you.